Okay, so last time we've seen this selection sorting, right? Remember, with this selection sorting we said that the idea behind it is that we take the first element of an array and then we try to compare it to find if it is the minimum, and if when we find the minimum we're going to be putting it in the first element and swapping it with this first element of the array, and then we keep doing so. Once we find the minimum in the first minimum, then we find the remaining minimum, the minimum of the remaining values, and when we find it, we just swap it with the second element, and then we keep doing this. We find the minimum, swap it with the third element, fourth element, and so on, until we finally end up with the full array that is sorted. So that's how we, first of all, we implemented this with numbers. Remember, we just made it easy. Like we had this implementation when we take only an array of numbers, and with that array we just were looking for the minimum, the position of the minimum, and then we take for every element of the array up to the last one. Why? Because actually we start from this one, and then we keep selecting each of the elements until this one, because we'd like to compare this one with the remaining one. That's why we don't go until array list, but array list -1. That's why the -1 here, because we're picking up these elements until this one. So because we take this and we compare it with the rest, and then we take this one, we compare it with the rest, until we take this one and compare it with the rest. We don't need to take this one and then we have nothing to compare it with. So that's why we stop at array -1. This k -1 is what they say. Array that length -1. I mean, it's before -1. And then when we select one of these, this is when we get this I. So the I is, we assume that this is the minimum, and then we are going to be comparing with the remaining. Now from the I plus 1 until the end, this is where we can, if the I is 0, then the I plus 1 is this one until the end. And the same thing, if I is 1, then the I plus 1 is 2 until the end. And that's why what we're doing here. We're going to compare the values. If we can find the value at the first element, is it, I mean, smaller than the one in that we, if the value at the minimum, is it greater than any of those numbers? And if we find one of the numbers that is smaller than the minimum that we assumed was the minimum, we're going to remember, oh, this is our new minimum. So with this 4 here, what we do, from here until the last, we compare, we try to find the minimum. So is this the minimum? We said, is this bigger than this one? No. Okay, we don't do anything. This is bigger than this one? Yes. Okay, then maybe 25 is the minimum. So we remember 25. And then we keep now checking, is this one, I mean, smaller than this one? No. Okay, keep going. This one smaller than the minimum that we found? No. Until we find someone else, another number, this 15, which is smaller than this minimum that we thought, and then now the k is going to be here, and then we keep going until we reach the end. And then when we pass here, we know that we have located the minimum among all these, and then we put it, when we have it here, we ended up finishing this loop. Then we need to check, are the minimum that we assumed to be the first one, is it different from the minimum that we found? So just to, in case, if we found that the minimum has changed, and then because we found another minimum in the array, we are going to be doing the swapping. And remember, we need always a third variable in order to make the swapping between two variables. So if I'd like to swap between these two, I had to use a temp to put one of these, the array I put it in temp, and then the minimum now is going to be at the first position because I starts from 0 and so on. And then after doing the swapping, we move the I to the next element. So after doing the swapping, we swapped this 15 with the first element. Then now I becomes 1, and we do the same thing again. So that's why you see pass 1, pass 2, etc. So that was the idea behind the selection sort. That's what we did, and we used it. If you remember, we tested it also. Let me just maybe do something like this to see it before and after. And I'm just commenting the one we're using the array of students. Maybe just I'm going to rename this to students. Oh no, because now I need to change something to make it work with this A. So this is going to be, let's name it A, so I can use it for both cases. Of course, this is going to be complaining now. I'm going to be commenting this, control and then comment. So now I'm commenting this just to have this A, which is a double array of doubles, and then I'm going to be displaying the array before and the array after the sorting. So this is selection sort. I'm going to be calling this one over here, and it's going to be, I'm going to be displaying the values before and after sorting. So let's run and see. So these are the values before, and remember these are doubles, that's why I'm seeing 5 point something. And now these are the values after the sorting, and you can see that they are sorted. So this is done using this selection sort. And why is it called selection sort? Because I select the first element, compare it with the rest until I find the minimum, and then select the second element, compare it. This is why they call it, and something like that. And then the other thing that we did after doing this, we wanted to make the selection sort work with any class, not only a class that is, a data type that is a number. So I'm going to uncomment this, control and then this comments. And now I'm using A again. Well, it's the same. I don't have to. Now the A that I'm using is going to be not the A which is a double, but the A that is, okay, I forgot to change this, that is using an array of classes, of elements of class type student. And then this is the student. When we have just this ID, name, and then GPA, we have only one constructor just to being able to do this. Sorry, to be able to do this. So I can create an instance of student and put the values inside of it at the same time. So that's why I had to use this constructor over here. I have this equals because I need to have this compare to, and the toString is just to display, so I can display it this way. So the compare to comes because I'm implementing comparable. And what is the idea behind implementing comparable? Because we would like to be able to compare, but also we would like to have some general algorithm that is going to be sorting any comparable class for any class. Not only students, we are doing it for anything that can compare, that can be comparable, that implements this comparable. So, but the comparable, as you said, is just, it allows to have a method called compare to, and that method, what it does, it just first of all downcasts to the data type that we're using, and then make sure that if it's equal, it returns 0. If it's smaller than this one is smaller than the other one, then it's minus, or else it's positive. And I decide based on what which one is greater. So here, as you can see, I decided that it's based on the ID. I can choose no. I want to sort them based on their GPA, for example. So if they're equal, there's no. I want. If I look at the equals, what I did, I just want them to have the same name, same ID, same GPA. If one of these conditions, if one of these are not equal, I'm going to return false. If all these are equal, then I'm going to return in true. So I assume that two students are equal, two instances are equal of students if they have the same ID, same name, and same GPA. But then when I would like to compare them, if I find them equal, I'm going to return 0. But if I'd like to make who is smaller than who, I would like to find out based on what I'm going to be doing that, and I selected based on this, on the GPA, for example. Last time we used ID. Let's use it. Let's sort them based on the GPA. Yes.
Excuse me, I want to see the difference between compared to and equals.
Equals is just one. Equals is used by compared to. Equals is checking whether an object, an instance, is equals to another instance. So this instance of a student is if it's equal to the other instance that we sent between as an argument. So that's what this is used by compare to check if it's equal. It's one condition of the compare to. Well, in the equals, what I'm doing is just I'm checking if. Well, I can put it in one line. Maybe this is why maybe you're asking the question. You find it a bit confusing. What I can do, for example, I can put if the name are different, or the IDs are different, or the GPAs are different. I think this might be easier to get the condition. So if the name are different, or the ID are different, or the GPA are different, then I'm going to return false. They're not equal. If one of these is true, they're not equal. But if it's not the case, then they're equal. Okay. So that's what I'm doing. Or you can reverse this to make if this is equal, then return true, else return false, something like that. So that's what I'm doing. I'm just checking if they're equal based on the conditions. Yes. If you have more than, I do have more than 3 objects. I have 4 objects here in the array. The compare to takes 2 by 2. When we compare only 2 by 2. You know, if you look at the algorithm that we use with the array, we only compare 2 by 2, right? We're going to be doing exactly the same thing. We're comparing 2 instead of 2 doubles or 2 ints. I'm going to be comparing 2 students. That's why it's not a big deal to change, to move from this double or ints to primitive, from primitive data types to class data types. Here, compare to. Okay. I don't get your question now. You're talking about equals or compare to? You're talking about the names or equals? Sorry, compare to or equals? Inside compare to. Okay. So here you're talking about maybe you're talking about referring about this line, right? You're asking why did we use only this? You want to compare on more than the GPA? Maybe. I don't understand the 3. What kind of 3 are you talking about? But am I using all the 3 of them?
No, what if we have 8? If we have 8,
yeah, if we want to add another thing, maybe compare with GPA.
Okay. If I understand your question correctly, what you're saying is, what happens if I have, like, imagine I have something like private int age, as you said, right?
And we want to compare between GPA and age.
But then this is what he did not say that. In his saying is, what if I have more than 3? So more than 3, well, I have more than 3 here. What's the problem? Am I compare between all of these? So it depends on what you want to do. How do you want to sort your students? Based on the age or based on the GPA and the age? It's all based on how do you want to compare them. You have to find a way how to compare them. You cannot compare, of course, a GPA with an ID. It doesn't make sense. You want to be comparing the same thing. But what you might be doing, for example, you want to include more things to compare before deciding this one is greater than the other one.
Can we?
You can. For example, you can say that, but it's going to be much more complicated because you're trying to do something more complicated. But let's say you want to, if this is less than that, and you want to have also this ID is less than the other ID, then you're going to decide this one is smaller. So if one of the conditions is false, then you're going to assume that it's not smaller, it's bigger. But you're going to be having some weird situations when the GPA is smaller, but then the ID is different, and how do you sort? It's going to be complicated for you to follow up. But you can put any condition that based on your class, how do you compare these two students? Generally, you need to compare them based on some criteria. But if your criteria includes many variables, it's up to you. But just keep track of what you're doing. At the end, what we want, you return 0, a minus, or a positive. But you decide how you're going to be comparing, how you're going to be returning the 0 and the minus and the positive. For example, here, if you notice the equals, I used equals. But why use equals? I could have used, for example, if the ID is different, that's fine. If the ID is the same, even if they have the same name, say, or a different GPA, or different name, different GPA, I'm going to assume that having the same ID is, to me, they're equal. So we can have like two students with the same ID, but different name, different GPA, and I'm still going to consider them to be equal. By using compare to, I'm going to say it returns 0. And then I don't need to use this one, because I used this one, if you remember, just because I wanted to have this compared to. So it's up to me, again, I don't know if I got the question right, but it's up to me to decide how these two objects are going to be considered to be equal, and what is the condition that will make one greater than the other one. If you want to have some more complicated testings, it's up to you. I'm just showing you just an example of, we can have something that makes a little bit of sense, and I'm sorting them based on one thing. Either it's the GPA, or the ID, or the name, or age, or whatever. Did I answer your question? I'm not sure if I answered your question. Okay. Okay, alhamdulillah. So now here, I'm just considering them to be smaller than how to decide between which one is greater than the other, but just looking at the GPA. If one of the GPAs is, this GPA is smaller than the other GPA, I'm going to return -1. If it's not the case, that means it's greater because they're not equal. And that's it. The toString is just about to display them. So now I need to, in order to be able to sort them, I'm not going to be using this one. If you see, when I'm selecting this one, it means detected that this A is not of double that can be, I'm not going to be run this one, but this is the one that is going to be run. And I just would like to make it a little bit close to the other one so we can compare the two, if it's possible to have them both. So you can see from this, the only thing that was changed here is the comparable. I did not put student because I wanted to work with any class. So anything, this method will work with anything that implements comparable. So if I have another class called cars, for example, or car, and then I'm implementing comparable, then I can also sort it. So whatever, I'm just putting anything. I can, instead of an array of students, I can now sort an array of cars or whatever. So that's the advantage of using comparable here. But in order for me to be able to do that, actually, I need to just make sure that when I'm using this comparison, the only thing that changes, if you look, everything is the same. This line the same, this line is the same, this line is the same. Look here. This line is also the same. It started to change from here. This is the only change, actually. The only change from this and this is this comparable as the data type of the array, and the way I'm comparing. I cannot put array of k less than, like here, less than minimum array of minimum position, because now there's no such thing as this less than, but I can use compare to. So now this becomes the first one, compare it to the other one. And if it's the comparison, this is returning a negative number, then I know that this one is smaller than this one, than the other one, and then I'm going to remember it. And this is what I'm doing. I would like to check if this one is less than the other one, and that's what I'm doing. All the rest remains exactly the same, except again for this temporary file, it's comparable instead of double, in order to be able to get the value and swap it. Yes?
Could you again about the file of less than 0?
This one?
No, the compare.
Actually, this one need to be converted just compare to, because we can use the less than greater than with numbers when our array was of numbers, but now when our arrays are of some kind of class type, I cannot use less than. So that's why I'm using comparable. And this compare to, that's why I'm using compare to. Compare to, what it does, it takes this is the first one that's going to be in this, and compare it to the other. So this is going to be the other, and this. And this, if we look at it, oh no. If I look at here, this and the other, so this is the k, and the other is the minimum. And I'm checking if this is smaller than this one, because now how to know if it's smaller? It just returns -1. So that's why I need to ask, is this going to return -1? If it returns -1, or I can just put exactly, because I know exactly how it's going to return, for example, -1. But just I'm doing something that's, I would like it to work with anything. So because we said that it should be something negative, maybe in car I'm going to throw -2 if one is smaller than the other one. It's still negative, it applies the same idea, but then if I put -2 in one and -1, it's better for me not to put equals to -1. Just something less than 0, greater than 0, and whatever. It's going to be working for all of them. So that's the only thing that I had to change to make it work with all objects that are comparable again. So that was the selection sort. Now, if we understood this, the other one, which is the second thing that we would like to look at, is the bubble sort. It's something quite similar, except that it's a bit different on how it works, and how it ends up doing things. In the selection sort, we find the minimum and we put it at the first place. In the bubble sort, or the second sort that we're going to be looking at, it's quite the opposite. It's try to put the maximum, start with the maximum, and then go down. But it do it in a different way. Instead of just swapping the compare to and less than and greater than, it does it in a different way. What is the way? This is like some pseudocode to explain what it does. We do it in different passes. We start with the first pass, and then what is this kind of first pass? This is what we mean with this first pass. The first pass is we start with the first element, and then we compare the two. Actually, what this is doing, basically, it takes, for every pass, it checks the elements if they are in the right order. For example, start with here. Is this one at the right order with this one? Yes. Which means this one is smaller than this one. If it's yes, then we do nothing. If it's no, okay, swap these two. And then go to the next one. Are they equal? Are they of the same order? If they're the same, swap them again. Let me maybe look at.
So the bubble sort makes making two swaps.
Swap. It makes many swaps. I mean, it's going to swap many if they are not in the same order. So check what happens actually from the number of passes. While this number of passes is different, is smaller than the number of arrays. What this means, for every element, look, there's a while, and then inside the while we're going to be doing a for. For every pass, we're going to be doing how many passes? As many as how many elements do we have? I mean, -1, because we're doing the. So how many elements do we have here? 1, 2, 3, 4, 5, 6, 7, 8. We're going to be doing 7 passes. Same principle like with the other one. If you remember, we had 8, but then we did 7 passes because we took the first one and compared, tried to find the minimum among the others. We're going to be doing the same similar things, except that for every pass, I'm going to check the elements of the arrays. Are they on the right position? If they are the right position, I mean the two next to each other, are they sorted correctly? This one is smaller than the other one. If no, swap them. Put them in the right order. Even if they're far away, this is not the minimum, but it's going to be swapping them until what happens because of this swapping is that the bigger is going to become on the right side. So, and then I'm going to, if this one bigger, I'm going to bigger, so I'm going to swap them until this one becomes, the bigger becomes at the end. And then do it again and try to find the bigger and then put it there. So it's, instead of finding the minimum by just looking at the minimum and finding it every time, or the maximum and put it at the maximum, the last one, we are doing some swapping, and they call it bubble sort or exchange sort. I'm trying to find. Sometimes also, known as exchanged sort. And this is the main idea. Let me just show it to you now. I'm going to collapse these. We're going to be using the same values there. Let's start with these arrays, or this small. Let's start with the one with the primitive data types, and let's make them int because I don't want to see those numbers like that. So it will be easier. Let's make it int and int. So it's why I did this, because I just would like to see something. We didn't. No, we did. We didn't run the one with the students. One always. This is the one that I would like to keep to see it working with just ints. So this is just sorting them. Even if you notice that do the same numbers, they're going to be sorted together. Now what I'd like to do, instead of selection sort, I'm going to create something called bubble sort. And I'm giving it the A to work with. Bubble sort. It's going to tell me there's no bubble sort, and I'm going to create the method. And now if I click on it, I'm going to be finding it at the bottom. Let me put it a little bit here. Okay, so I'm going not to throw anything. In the bubble sort, what I need to do is the same idea. I need to go from all the elements. So let's do the same one, that's the number of passes that we said. Let's I just would like to do the same kind of variables and things. So while what? While the number of passes is smaller than the array, I call it A. I'm going to put a.length and then rename it. I'm going to do something. Let's rename this to array. Makes more sense. So what I'm doing here is that I'm going to be doing a for until reaching the, not the array.length, but array.length minus the number of passes. Why is it like this? We're going to see. No. Why is number of passes? Because the first time it's going to be 1, right? This number of passes is 1. So the first time is less array minus 1. Why are we doing this? If you look here, we're going to first time going to until this one, because every time we're going to be comparing with the previous one. But also after each pass, our array, the limit of our array becomes smaller, and then smaller by the number of passes. So we don't have to go all the way along, because these ones, we don't need to swap them. We know that we don't need to swap them. So that's why after each pass, we reduce the number, the arrays that we're doing. It's exactly the same thing, but in the opposite way that we were doing here. We were just increasing the I. If you remember, the I was increasing, and then we are not going to start from 0. We start from I wherever we start. Here's the same thing. We're not going to be ending until the end. We end just before. That's why if you pay attention, we're not going to be using less than. It's going to be less than or equal to this. And starting from 1. not from 0. But then how do we get the first element? Well, because here, well, let me just, maybe to avoid the confusion again, let me show this. See here, we start from 1, and then we're less or equal to -1. So why do we set from 1? Because when we compare the k with the k minus 1. Let's do the, I'm going to rename it to k, so it's going to be exactly the same thing. So we start from 1, and then it's less or equal to this minus the number of passes, and then we increment. And what happens here is that we are going to see if the array of k minus 1, the one in the left, if it's greater than the array of k, then I need to swap it. They're not on the right direction. The one in the left is greater than the one on the right. I want them to be sorted in ascending order, so normally the one that is smaller should be on the left, the one that is bigger should be on the right. And this is what I'm going to be doing. So int temp, I'm going to be using one of these, and then rate k minus 1. Sorry, it's this -1, and then array of k equal to temp. Now this is the swapping, and this is the for k, and this is the while. And I'm going to be doing this, but every time I finish with 1, I need to, the number of passes needs to be incremented. I started with the first pass, and then I'm trying to swap all the rest if I find them not in the rest order. And then when after the end of my swapping, the maximum should be at the end. Now I need to increase the number of passes because it was 1. I want it now to be 2 because I don't want to stop at the end. I don't want to stop at here. I want to stop 1 element before. So that's why I'm going to be using this plus plus. So it was 1, it will become 2, 3, and 4, and hopefully this is going to be sorting them. So let's see them sorted based on the bubble sort. This is the unsorted, and this one is sorted using the bubble sort. Now the thing is, normally, and this is something you're going to be seeing maybe in some others. Yes?
Can you run it again? Why it's sorted from... okay.
Let's try to run it step by step, shall we? The output is the same, just to make sure that actually it sorts them. So the output is going to be the same, but we just would like to understand how it works. So in order for me to understand how it works, I'm going just to start, well, it's going to take us a long time with a big array. Let's make the array smaller so we can easily follow up. What about this? Something like this. Yes? Yes?
Before the sorting method, you was like taking the smallest value and put it in the first.
In the first place.
This one, the opposite. You take the highest value in the last.
Exactly. But the way it works was different. In the first one, we was looking for the minimum. When we find the minimum, we swap. Here, we're doing so many swaps. We're swapping so many times. And this is what I'd like to be doing it. In order for me to do it, let me start with this paint.net. If I find it, yeah, this one. I just would like to draw this array and then follow it up. I'm going to run this. This is the array. I'm going to see that. I mean, well, maybe this is like a weird case. No, it's not a weird case because it's not all sorted in the wrong order. So what I'm going to be doing, I'm going to be drawing this array, and I'm going to be showing every time what is going to be happening. So it was 5, 8, 4, 2. And every time I'm going to see what is going to be my array after I do some changes. And just the only thing that I need now to follow up is the number of passes. I'll call it NP. Okay, it starts with 1, and the k of for the array. This is what I'm going to be following up. This is 0, 1, 2, and 3. Fine. So I'm going to be running this once every time, so we can every step I'm going to be making sure that I understand each one of these steps. And if you have any question, just stop me so we can make sure that we understand how it works internally. So we start with the number of passes to be 1. Okay. Now we start with the for loop with k equal to 1. K is less than or equal, and then we're going to be putting 1 in k. And then the maximum for k is array.length minus number of passes. What is that? What's the array of length minus passes? So the max, let me put now the max, which is the max k. This is array.length minus passes is equal to what? Array.length equals to what here? 4. 4 minus number of passes, so it's going to become 3, right? So k is going to be equal 1, 2, and 3. So k is equal 1. I'm not starting at 0. Did you notice? I'm starting here. But that's fine, because when I'm comparing k minus 1. So that's the thing. Okay, first we put 1 in k. Is 1 less than 3? Yes, get inside. Array of k minus 1. K minus 1 is equal to 0. So now array of 0, I'm comparing this one. Is it greater than array of k? No? So I'm not doing anything. So I'm not getting inside this if. Next thing, k plus plus. K becomes 2. Is 2 less than 3 or equal? Remember, there's an equal there. Yes. Okay, get inside. Is array of k minus 1, so k minus 1, 2 minus 1 is 1. Is this one greater than array of k, array of 2? Yes. So what is going to do? I'm going to swap them. So swapping them means this becomes 4 and this becomes 8. So do you notice that I'm pushing the 8 to the right? Now, now that I have done this, again, I'm going to increment k. K becomes 3. Is 3 less or equal to 3? Yes. Get inside. Now, array of k minus 1, array of 2, which is equal to? Is 8 greater than 2?
Yeah.
Yes. Swap them. So put the 2 here and put the 8 here. Now k becomes 4. Is 4 less than or equal to 3? No. I'm getting out of this for loop and I have to increment the number of passes. The number of passes now becomes 2. So when the number of passes becoming 2, I need to erase a couple of things now. And how to erase those? I'm going to erase by maybe doing something like this. And no, let me draw field shape with outline, whatever. Oh, nice. So I'm going to draw it like this. That's erasing. So I'm going to erase another one. We said this is 2. And this should be 2. I'm going to just put the 2 now. It's so much easier when you have a pen. Well, that was should have been a brush, maybe. Okay, and this is 4. So let's put this here. Okay, and that's it. Let's just now go back to the k because we would like to need the k to be again empty. And this maximum is going to change as well. Because now the maximum is going to be array dot length minus number of passes, which is 2. Because 4 minus 2 is 2. And then the number of passes actually was become 2 is 2 less than 4. And it's strictly less than array dot length, yes. I get in here. And then I put 1 in k again. And then if you notice, I'm going to be stopping at k equal 2. So I'm not going to be checking for the 3 because we know that the 3 now is set up. The maximum is at the right position. And we're going to be doing this again. Starting from k equal to 1. Is k less or equal to 2? Yes. So get inside. Array of k minus 1. K minus 1, this is 1. Compare this 5. Is 5 greater than 4? Yes. Swap them. So this becomes 4. Maybe let me erase directly. It will be easier. So this becomes 4. And this 5. And erase this one. And then the k becomes 2. Because after this, I finished the comparison. I have to increment k and then ask the question again. So is 2 less or equal to 2? Yes. And then I'm going to compare. Is 5 greater than 2? Yes. Swap them again. So this again becomes 2. And this becomes 5. So you got the point. Every time the maximum is going to be going to the right, and then k is incremented, becomes 3. 3 is not less than 2. Get out. Increment then the number of passes to 3, and so on. You can see that now it's going to be swapping from again maximum becomes 1, and k becomes 1, and then I'm going to be having only to compare between 4 and 2. Is this comparable? Is this greater than this one? Yes. So I'm going to swap them. This becomes 2. This becomes 4. And then the number of passes now becomes 4. And is 4 less than 4? No. So I get out of the while, and then I have it sorted. So that's what it did. It just started by putting the last one at the last, the bigger one at the last, and then the second biggest one, and the second last, and so on. This is the bubble sort. So it works differently. Okay. We've seen it working with this. If we would like to have something similar that works with an array, with any comparable, it's quite the same thing, because we don't need to do much change, except if I'd like to have something like comparable here. Now this has to be, instead of int, it has to be comparable, and I cannot just have this kind of comparison. Check, it's not less than. Yes, compare to, and then if it's bigger than 0, then do that, because if this one is bigger than this one, it's going to be 0, bigger than 0. So that's why. That's the only thing I need to do, and then this bubble sort now is going to be working with students. And this is the bubble sort. I just need to put maybe this one, so I can see them each one in one line. If I run, remember I'm comparing based on the GPA, so I can have before they were sorted in different orders, but now based on the GPA they're in this order.
So is there any cases that we necessarily need instead of selection.
Okay, now this how to choose which one to use. Which one might be I mean more interesting to use. I mean, in order to do that, this is another discussion which involves something that I didn't talk about, how to compare to algorithms, because there's something related to efficiency, how fast, how many times it executes, it does some comparisons. So, in order to be able to compare them, you need to do these kind of things that I don't want to get into that. Why? For a very interesting reason, because it needs more time to talk about it. And you have to talk about this algorithm complexity. And we didn't, this was in the first slide when we were talking about the comparable interface. And if you'd like to have an idea, and this is how you compare them. Is it quadratic time, n log n time, or linear, or log n, or polynomial? And this is the less time efficient and the more time efficient. So if you have some, but how do you get this? This n is the number of time it repeats, the number of repetitions. So there's a lot of different kind of factors that you try to find out. You have to sort, to categorize those algorithms into what kind of complexity it uses, and then so you can have a better idea which one takes more time than others, depending on if the n is small, this might be faster than when the n is big, this might be faster, these kind of things. And we don't have time for this. This is out of the scope of this course. Now, for the scope of this course, we just want you to be exposed to different ways to how to do things, and to open your mind to different kind of solutions to the same problem. The problem is the same, sorting them, but then the way to sort them, you can have different ways how to sort them. And every one of you should be able to just have some kind of thinking out of the box when you have to think about one solution to your problem. Don't always try to do things that exactly the same thing that you've seen before. You can try to come up with a new thing that gives you the same result based on your situation. And that's what I would like you to get from this sorting, this kind of differences between sorting. If you want to have more information, you can Google it. Just Google algorithm complexity, and then you're going to find a lot of different information about it. It's not complicated. It just takes more time, and we don't have much time. I just would like to give you more time for practicing this bubble sort and so on. So I'd like you to implement this bubble sort actually, and make it the same thing that we did last time. Convert this one to be working with the comparable, but then make this one work first, and then change it to using the comparable. Yes. Yes. Any questions before you start the practice?